Happy morning to all. Happy morning. Okay. Last class we discussed about the Arrhenius equation. It's a very important question, the Arrhenius equation. Please all of you learn that question. I hope that you maybe learn that question. Okay, anyhow today our learning objectives to learn about what are the factors affecting the rate of the reaction. What are the factors affecting the rate of the reaction? What is about the nature of the reaction? Nature of the reactant. The second one is the concentration of the reactant. The third one is the surface area of the reactant. The fourth one is the temperature of the reactant. And the fifth one is the effect of catalyst. That means presence of catalyst. The 5 points are important 3 mark question. And also it may be asked 2 mark question. Okay. 5 points. What are the factors affecting the reaction rate? Okay. First one, what is about the first point? The nature and the state of the reaction. Nature and the state of the reaction, the concentration of the reaction, and about the surface area of the reaction, temperature of the reaction, and about the presence of catalyst. Here, what is about the nature? What is about the nature? Here we are taking two reactions. One of the reactions, for example, the volumetric analysis, the redox reaction. Redox reaction means, what is about the redox? Both to oxidation and reduction. That we are saying redox reaction. The redox reactions involves the potassium permanganate versus ferrous ammonium sulfate. And this one is for an oxalic acid. Oxalic acid versus KMNO4, potassium permanganate. One of the reaction is fast and another one of the reaction is slow reaction. Okay, the oxalic acid versus KMNO4 is a slow reaction. And the ferrous ammonium sulfate versus KMNO4 is the fast reaction. Why it is happened? It is respect to the nature of the reactant. And also we can think about that gas reaction. That is sodium metal versus iodine vapor. This is faster than sodium metal, solid sodium metal, and also solid iodine. Somewhat faster, gaseous phase is somewhat faster. So it is respect to the nature of the reactant. Next about the concentration. If the concentration is increased, the rate of the reaction is also increased. We have some examples about the concentration of reaction and about the surface area, nature of the surface area of the reactant. That we can be taken as calcium carbonate, powdered calcium carbonate and marble piece. That is also calcium carbonate. The powdered calcium carbonate having the particle size. The particle size is decrease in particle size. It is more reactive than marble calcium carbonate. And about the catalyst. What is about the catalyst? A substance which alters the rate of the reaction. The substance which is altered, it may be speed up or slow up the reaction. That is called about the catalyst. Let us begin to discuss one by one. Okay. Factors affecting the reaction rate. Anyhow, today our learning objectives to learn about the factors affecting the reaction rate. It's a very important question for the 2 mark question. Write what are the factors affecting the reaction rate. That's the question. That is, first one is the nature and state of the reactant. Second one, the concentration of the reactant. The third one is the surface area of the reactant. The fourth one is the temperature of the reaction. And the last one is the presence of a catalyst. We have 5 points. We should be learned the 5 points. The very important 5 points. One is about the nature and state of the reactant. Nature and state of the reactant. That's the first point. Nature and state of the reactant. Second one, concentration of the reactant. Concentration of the reactant. The third one is surface area. Area of the reactant. Fourth one is temperature of the reaction. Of the reaction. Fifth one, presence of a catalyst. These are the 5 points about the 2 mark, or sometimes maybe asked about the 3 mark question. What are the factors affecting the reaction rate? The first about the nature. What is about the nature of the reactant? Here we can be say the nature, we can be say two analysis of one of the reaction, volumetric analysis. For the first one is the volumetric analysis. That is the redox reaction between the ferrous ammonium sulfate and also the KMnO4. Second one is redox reaction between oxalic acid and KMnO4. It explains about the nature of the reactant. First, before that, what is about the nature and state of the reactant? What is about the nature and state of the reaction? We know that all the chemical reaction involving breaking a certain existing bond of the reactant and forming a new bond, am I right? Which leads to the product. That is, the chemical reaction involving certain existing bond of the reactant and forming a new bond which leads to the product, am I right? However, the net energy involved in this process is depend on the nature of the reactant. The net energy for this reaction having some net energy, am I right? This net energy involved in this process is depend on the nature of the reactant. So we can be say the rates are different from different reactants. Hence the reaction rates are different for different reaction. That's the point. What is about the rate of the reaction? In this condition, the rates are different for different reaction. That is explained by the redox reaction. What is about the redox reaction? Redox reaction means we can see both oxidation and reduction reaction. What is about the oxidation? Already we learned about the oxidation and reduction. Okay, about the oxidation reaction, and about the reduction reaction. Next we can discuss about the redox reaction. Okay, we can discuss about redox reaction between ferrous ammonium sulfate. FAS means ferrous ammonium sulfate and KMnO4. That is potassium permanganate. One more reaction, the redox reaction between, that is the oxalic acid and KMnO4. That means it is one of the volumetric analysis. First of all, we should be learn about the volumetric analysis. What is about the volumetric analysis? Volumetric analysis. That is here means by using the volumetric analysis, we can estimate the ferrous ammonium sulfate. Okay, we can estimate the ferrous ammonium sulfate. For example, I think that in your textbook, page number 265, we have some practical. Page number 265. Okay, page number 265 to 279. We have some practical area regarding for the volumetric analysis. Okay, volumetric analysis. Here that area we have, you have to estimate ferrous sulfate dissolved in 750 ml of the given unknown solution. Okay, so you are given for the standard solution is a ferrous ammonium sulfate. You have to estimate what? Ferrous sulfate. Estimate ferrous sulfate, but it is one of an unknown solution. And also one of the standard solutions. Standard, we know one of the standard solution is FAS, ferrous ammonium sulfate. FAS. So we need one of the link solution. We need one of the linking solution that we can be sell as KMNO4. KMNO4. That is a potassium permanganate. So that we are saying about the titration. That part we are saying about the titration. What is that one? Titration. Here for this experiment, this practical, we have two titration. So one is about the titration versus linked KMNO4 versus standard FAS. Okay, titration 1. For the first practical, link. Which one is a link? KMNO4. Okay, KMNO4 means potassium permanganate. Link KMNO4 potassium permanganate versus standard ferrous ammonium sulfate. We get one of the normality. Normality of KMNO4 we get. Okay. Here for this practical, first of all we should be learn which one is the Beerot solution and which one is the pipette solution. For all the practical, Beerot solution is what? KMNO4. Beerot solution is KMNO4. Okay, potassium permanganate. Beerot solution, potassium permanganate. We are pipette out. We are pipetting some solution. Pipette solution. That we are taking ferrous ammonium sulfate for the first titration. The second titration is ferrous sulfate. Okay. For the first solution, first titration we are taking ferrous ammonium sulfate. Titration 1. Titration 1. Beerot solution is KMNO4, and about the pipette solution is what? Ferrous ammonium sulfate. Here the ferrous ammonium sulfate is a standard solution. The KMNO4 is a linked solution. Am I right? Linked. I told you that linked solution. First titration between KMNO4, linked potassium permanganate versus standard ferrous ammonium sulfate. Okay. Then next about, we should be add some acid. Acid should be added. Acid added. Then here we are adding 20 ml of 2N dilute sulfuric acid is added. Okay. 20 ml of 2N dilute sulfuric acid is added. Okay. Next about here the temperature for the volumetric analysis for the ferrous sulfate, ferrous ammonium sulfate versus KMNO4. It's we are saying that the lab temperature for the oxalic acid only for the oxalic acid we need a 60 degrees Celsius. Okay, 60 degrees. And about the indicator is a self indicator because the potassium permanganate is a pink color, am I right? So indicator is a self indicator. End point appearance of pale permanent pink color that we shall be learned during the practical time. Okay, this is just only for the introduction about that. I told you that volumetric analysis. This is about the volumetric analysis. Okay. Anyhow, here what is about the redox reaction? Here, one of an oxalate ion by KMNO4 is relatively slow reaction. That is, here the redox reaction between oxalic acid and KMNO4 is the which reaction? Slow reaction. While we are comparing between redox reaction between FAS and KMNO4, that's a point. It's a very important point. What's about that point? That is the redox reaction between oxalic acid and KMNO4 is relatively slow compared to the reaction between FAS and KMNO4. For this redox reaction between oxalic acid and KMNO4, the temperature is, I told you about the temperature is 60 degree. Okay, don't forget that 60 degrees Celsius for this redox reaction between oxalic acid, how much? 60 degrees Celsius. While the redox reaction between ferrous ammonium sulfate and KMNO4 is a lab temperature. Okay? It's a lab temperature. So why it is one of the reaction is slow reaction and one of the reaction is fast reaction? Why? Due to the factors affecting the reaction rate. That is, we are saying that nature and the state of the reaction. That is, depend on the nature of the reactant. This process is depend on the nature of the reactants. So, the rates are different for different reaction. The reaction rates are different for different reaction. Here? Okay, here, what is the concept? What is about the first concept? The nature and the state of the reactants. The first point about that, the volumetric, from the volumetric analysis, redox reaction between ferrous ammonium sulfate and KMNO4, redox reaction between oxalic acid and KMNO4. That's a 2 point. This for these two experiments, one is low. One of the reaction is relatively slow compared to other reaction. The slow reaction, we need the temperature is 60 degrees Celsius. Okay, so anyhow, the rates are different for different reactants. The rates are different for different reactions. That's the first point. Next, again we have some more example. That is, we can be saying the physical state. About the physical state also play a very important role for the rate of the reaction. Physical state. For example, the gas phase are faster as compared to the solid state. Okay. That means gas phase reactions are faster as compared to the reaction involved solid or liquid reactant. Gas phase, okay, gas phase. Faster as we are comparing to solid or liquid phase. Okay, faster than. Okay, that's the point. Here, the reason is, what is the reason? The reaction between sodium metal, okay, sodium metal and iodine vapor. Sodium metal and iodine vapor. Okay, sodium metal and iodine vapor is faster than solid sodium and also solid iodine. Solid sodium and solid iodine. Okay. So what is about the gas phase? Gas phase reactions are faster as compared to the reaction involved solid or liquid reactants. What is about this point? One of the physical state of the reactants also play an important role to the influence of the rate of the reactions. Anyhow, gas phase, don't forget that gas phase reactions are faster as compared to solid or liquid reactants. Okay, solids or liquid reactions. For example, sodium metals and also iodine vapor. These two reactants is faster than in solid sodium and also solid iodine. We can take another more example that we can take inorganic qualitative analysis. That is, we are taking potassium iodide. What is the formula for potassium iodide? Potassium iodide. Formula for potassium iodide. Already we learned the fifth lesson. Potassium iodide is Ki, potassium iodide. Am I right? Here, the potassium iodide is a colorless. Potassium iodide is a what? A colorless solution. Am I right? Colorless. And we are taking lead nitrate, PbNO3. Lead nitrate. Anyhow, potassium iodide reacts with lead nitrate. We get the lead is combines with iodine to form. Lead combines with iodine to form lead iodide. Okay. Here, potassium iodide combines with lead nitrate. Here, lead react with iodine to form, we get lead iodide. Okay. And also potassium combines with nitrate to form, we get potassium nitrate. Okay, clear? Anyhow, what is the color when the color is appear? Potassium iodide, we get a yellow precipitate of potassium iodide, yellow precipitate. This is an immediately we appear the yellow precipitate immediately. Whereas, suppose this is an aqueous solution. I am saying about the aqueous solution. That we can be say liquid state. Am I right? Solid, liquid, vapor. Am I right? Liquid state. About the solid state, we are taking solid potassium iodide plus solid lead nitrate. Okay, here in aqueous solution, potassium iodide solution reacts with lead nitrate solution, we get a yellow precipitates of lead iodide, PBI, potassium iodide, lead iodide, PBI, and also we get potassium nitrate. Okay, that is immediate yellow precipitate. Here we are taking solid potassium iodide and solid lead nitrate solution. Here also same, we get what other product is obtained? Lead iodide plus potassium nitrate, KNO3. Potassium combines with nitrate to form potassium nitrate. Here This reaction is very slow. This reaction is fast. This is slow. Slow. This is what? Fast. Here, aqueous solution is somewhat fast, and about the solid is somewhat the slow reaction. So we can be saying nature and state of the reaction depend on the nature of the reactants is depends upon the nature of the reactant. We can be say like that. That is, rates are different for different reaction. The reaction rates are different for different reactants. Okay. Clear? So anyhow, one of the reaction is fast and one of the same reaction, that is a different state, whether it may be a solid state or liquid state or gaseous state. I told you about the gaseous state. One of the reaction is very fast. That means sodium metal and iodine vapor. Sodium metal and iodine vapor is faster than solid sodium and solid iodine. That is sort of the reaction, fast. In this case, aqueous solution, potassium iodide solution is a colorless, and lead nitrate solution is also colorless, and we are mixing the both solution, we get an yellow precipitate of potassium iodide. This reaction is fast as we are comparing to solid state of potassium iodide and solid state of lead nitrate. We get potassium iodide and lead iodide and potassium nitrate. Here, this reaction is very slow. This is about, we can be say about the nature and state of the reaction. Next, about the concentration of the reactant. What is about the concentration? Here, the rate of the reaction depends upon the number of collision between reacting molecule. Okay, about the concentration. This theory is based on the collision theory. Which theory? Here, this is the concentration of the reactant. Concentration of the reactant. Here, concentration of the reactant can be explained by the basis of collision theory. Collision theory. According to this theory, the rate of the reaction depends upon the number of collision between the reacting molecule. That's the point. Okay. According to the collision theory, the rate of the reaction depends upon the number of collision between the reacting molecule. Already we learned about the collision theory, am I right? Anyhow, what is about the concentration of the reactant? The rate of the reaction increases with the increase in the concentration of the reactant. The rate of the reaction, okay, the rate of the reaction increases. Here, the rate of the reaction is increases. Okay, the rate of the reaction is increases in the increase in the concentration of the reactant. Here we can be explained by which theory? Collision theory. Which theory? Collision theory. According to this theory, the rate of the reaction depends upon the number of collision between the reacting molecule. Don't forget that. What is about the theory? Collision theory means the rate of the reaction depends upon number of collision between the reacting molecule. Okay. Clear? So, higher the concentration, suppose the concentration of the reactant is higher, greater the possibility for collision, and hence the rate is very higher. Okay? So, higher the concentration, if the concentration is high, collision is also high. Rate is also high. Okay? Higher the concentration, greater the possibility for collision. Concentration is high, greater is the possibility for collision, and also we can be say rate also high. Okay? So what is about the concentration of the reaction? The rate of the reaction increases with increase the concentration of the reactant. Here we can be explained by collision theory. What is about the collision theory? The rate of the reaction depends upon the number of collision between the reacting molecule. The rate of the reaction depends upon the number of collision between the reacting molecule. The rate of the reaction depends upon the number of collision between the reacting molecule. Higher the concentration, greater the possibility for collision. Okay? Next about the effect of surface area. These are all we learned in the 10th grade, am I right? We are learning the 10th grade, effect of surface area. For this, we are taking one of the reaction between calcium carbonate and also dilute hydrochloric acid. Okay, the reaction between calcium carbonate. So, first of all, we are right. The effect of surface area of the reactant. Surface area. Okay. Here, in heterogeneous reaction, the surface area of the solid reactant play a very important role in the rate of the reaction. Okay, here for the given mass of the reactant, what of this given mass may be 5 gram or 10 gram or 15 gram. For a given mass of the reactant, when the particle size is decreases, the surface area increases. Okay, here the particle size is decreases. Here the powdered, we are saying, we can be powdered calcium carbonate, and also we can be saying a solid calcium carbonate. Then we are saying marble piece. Which one have the large surface area, high surface area. Here, calcium carbonate, then we are saying marble. Okay, marble we are saying. Here, calcium carbonate reacts with dilute HCl. Powdered calcium carbonate also reacts with dilute HCl. Which reaction is fast? Which reaction is slow? That's the question. Here, the powdered calcium carbonate reacts with dilute hydrochloric acid is much faster than the marble calcium carbonate and dilute hydrochloric acid. We can be say this reaction is slow reaction. So, how can we say about this? When the particle size decreases, surface area increases. The particle size decreases. The powdered calcium carbonate, the particle size are small, decreases. While in the case of marble calcium carbonate, the particle size is big size. So, here having smaller surface area, less surface area as we are comparing. The marble calcium carbonate having more surface area. So here powdered calcium carbonate is easily react with dilute hydrochloric acid. Okay, here the particle size is very much decreased. The particle size is decreases. Small particle size. Here the particle size is big size. Okay, so as we can be saying, the marble calcium carbonate reacts with dilute hydrochloric acid is slow reaction. One of the slow reaction. The powdered calcium carbonate plus dilute hydrochloric acid is a much faster reaction. Next about the effect of catalyst, presence of a catalyst, effect of presence of a catalyst. First of all, what is about the catalyst? Catalyst is a substance which alters the rate of the chemical reaction. Okay. Effect of D. Effect of presence of catalyst. Here catalyst, one of the important word, catalyst. Here what is about the catalyst? It is one of the substance. Okay, catalyst means it is one of the substance. Here, this substance can be altered. The substance which can be altered. Alter means it can be changed. Okay, the rate of the reaction without itself undergoing any permanent chemical change. That's the important point. The catalyst is a substance. It is one of the substance which alters the rate of the reaction. It can be modified the rate of the reaction without itself undergoing. That's the condition. Without itself undergoing any permanent change, any permanent chemical change. Okay. Here, it may be participate in the reaction but again regenerate at the end of the reaction. That's the main character about the catalyst. The catalyst may participate in the reaction. It may be participate in the reaction but again regenerate at the end of the reaction. Okay. So, effect of presence of a catalyst. Here, what is we are going to learn about that? What of the catalyst? The catalyst, it may be speed up the reaction or slow up the reaction. That's the important point. Catalyst may be speed, increase the rate of the reaction. We can be say increase the rate of the reaction. Otherwise, we can be say decrease the rate of the reaction. This is about the catalyst. Here, we should be right about the definition for catalyst. A catalyst is a substance which alters, don't forget the name, alters the rate of the reaction without itself undergoing any permanent chemical change. What is about the catalyst? The catalyst is a substance which alters the rate of the reaction without itself undergoing any permanent change. It may be participate in the reaction. The catalyst may be participate in the reaction. Okay, may be participate in the reaction, but again it should be regenerated. That means reformed. Okay, regenerated at the end of the reaction. Here one more point. The energy of the activation is lower. In the presence of catalyst, energy, don't forget that. Energy of activation is lower. Okay, and hence the greater number of molecules can cross the energy barrier and change over to product. Okay, so it should be increase the rate of the reaction. That is the important point. Here, the energy of the activation is lower, hence the greater number of molecules. Okay, greater number of molecules can cross the energy barrier. Can cross the energy barrier. Okay, can cross the energy barrier and change over to product. Okay, now this converted to what? Product. By means of catalyst. Now increase by rate of the reaction. Okay. So, which are the points we learned that one? Which are the points? First one is about that nature of the nature and state of the reactant. Second point is about that concentration of the reactant. The third point is the surface area of the reactant. Next about the presence of a catalyst. About the presence of the catalyst. These are the important points. We learned that one. Anyhow, today I am giving the assignment. What is about the assignment? Please, 3-mark question. Write the factors which affecting. Write the factors affecting the reaction rate. Any two points. I think that we learn about that. We have four or five points. Any 2 points. Okay. This is about the assignment. Okay. What is about the assignment? Write the factors affecting the reaction rate. Okay, reaction rate. We have 5 points. What are 5 points? Nature and state of the reactant, concentration of the reactant, surface area of the reactant, temperature of the reaction, and presence of a catalyst. Okay, and you should be write any 2 points. Okay, for the assignment. Okay, anyhow, thank you all for joining you. Have a nice day.